Welcome to this video lecture on the subject electronic circuits. In this lecture, we are going to discuss about Class B amplifiers. So what is the need for Class B amplifiers? So these are used in large signal amplifiers, particularly in the applications audio power amplifiers and radio frequency amplifiers, which gives high efficiency and low distortion output. So what is meant by Class B amplifier? So this type of amplifier has the conduction angle of 180 degree or less than 180 degree, that is half cycle of the input signal. So this depends on the two complementary transistors used in push-pull configuration. So as compared in this diagrams, Class A is input signal obtained for the entire 360 degree, and for Class B it is 180 degree of the entire signal. So circuit diagram for Class B amplifiers. So it consists of two transistors, one is NPN and another one is PNP. So this configuration may have similar kind of transistor like 2 NPN or 2 PNP in push-pull configuration. So if it consists of NPN and PNP in this circuit, it is complementary symmetry push-pull configuration. So in this transistor 1 conducts for the positive cycle of the input signal and transistor 2 conducts for the negative cycle of the input signal. So it combines both the positive and negative cycles at the output of the amplifier. So this is the circuit for Class B amplifiers, and biasing is provided by the resistance R1, R2. So let's see the working of Class B push-pull amplifiers. So Class B push-pull has the two transformers. One is the input transformer, also known as the driver transformer, and other one is the connected to load, which is output transformer. So input transformer primary side input signal is applied. At the secondary of the input transformer, Q1, Q2 transistors are connected, where positive half cycle is conducted to the Q1 and negative half cycle is conducted by the Q2. So at the output of the collector, driver transformer is connected. So at the load, two half cycles are combined. So this type of circuit is known as the complementary symmetry push-pull Class B amplifier. So the one is the NPN type, the other one is the PNP type. And we can see the output of the Class B amplifiers. So for the sinusoidal variation in input signal, so output signal is obtained for the 180 degree. So the Q point is just on the x-axis, or it is above the x-axis. So it has zero DC bias as the transistor are biased at the cutoff region. What are the advantages of Class B amplifiers? So it provides lower power dissipation compared to Class A amplifier, and because it is using the two transformers at the input transformer and output transformer and also complementary symmetry, so two transistors conducted at the half cycle, so the power dissipation is less and also it provides high efficiency compared to Class A amplifier. So improved system reliability. These are the advantages of Class B amplifiers. And some disadvantages are crossover distortion and complexity. So the distortion present in the output of the Class B amplifier is known as the crossover distortion. It is the transistor is off during switching period from on to off. So this to be avoided. What are the applications of Class B amplifiers? So it is used in high efficiency amplifiers like signal processing, audio amplifiers and radio frequency amplifiers, servo motor control. Assessment. In a Class B amplifier, each active device conducts for 360 degree of the input signal, more than 180 but less than 360, 180 degree of the input signal, less than 90 degree of the input signal. So the answer is 180 degree of the input signal in Class B amplifiers. Next question, Class B amplifiers are most commonly implemented using single transistor configuration, push-pull configuration, cascade configuration, Darlington pair. So the answer is push-pull configuration. Thank you for listening this lecture.